Okay, average rate of change and instantaneous rate of change for chapter 2. We want to find the slope basically of curves. That's what we do. That's what you're going to be doing a lot in calculus. And luckily for you, a lot of calculus is slope. Okay, we pick 2 points or 1 point and we find the slope under or on that tangent or the area under the curve, which comes next with calculus. Okay, so I made 2 curves the same. We're going to find average rate of change and instantaneous rate of change. Remember, formula for slope is just the change in y over the change in x. Rise over run. Pick 2 y values, subtract them. Pick 2 x values, subtract them in the same order. Done. So if you have a curve and you want to find the average rate of change in an interval, okay, so this has to be in an interval.
Good morning, Ms. Moynihan. Can you return to the front office, please? Ms. Moynihan, can you come to the front office?
All you have to do is pick those points, get the y values. Now, if you don't have those y values, you're going to have to plug those x values into your equation, into your function, and you're going to extract those y values. That happens sometimes. So once you get those 2 points, you plug it into your formula. Sorry, let's talk more about this line. The average rate of change between 2 points, you draw a line through it, and we call this line a secant. A secant is any line that goes through 2 points on a curve. Okay, secant. And we just find the slope of that line, like we're in grade 9, the 3rd week of school. Okay, not the 3rd week, maybe the 6th. Okay, so y2 minus y1 over x2 minus x1. Okay, and this is going to find my slope. Okay, what's the difference between slope and rate of change? You guys remember that from grade 9? Most of the time in this chapter. I'll tell you where you're going to lose marks because this is so easy. Okay, you're going to lose marks because rate of change is generally multiple units. Kilometers per hour is a rate of change. You got kilometers and you have hour. If you divide kilometers by hour, nothing cancels out. They're different units. So you have to put that division right at the end, and we call it a unit, kilometers per hour. Okay, so don't forget your units. Every single time there's a word problem or it's distance, time, whatever the case may be, you need units for all rates of change. Done. Now when you have your numbers, you plug them in, you subtract them, you divide them, whatever you got to do, add your units, see you later. Average rate of change. Okay, I'll go into it more later, but that's the gist of it. I don't want to make it too complicated. I've got to save the complicated for this. Okay, instantaneous rate of change is actually the exact same thing. Just what's the difference? What makes this average rate of change and what's instantaneous? Yep.
Instantaneous is going to be 1 point.
Yeah, instantaneous is 1 point. So if I want to find the average rate of change on that point, how do you find slope of 1 point? Right? We would have to draw a tangent, right? But how do we draw a perfect tangent? What if we don't want to draw it? How do we algebraically find the slope of a tangent on a particular point? Okay, we don't really know how yet. So what we can do is we can imagine that we're finding average rate of change. So if the question says find instantaneous rate of change, you just pretend you're finding average rate of change. And we make a small adjustment to put it as close as possible to the instantaneous rate of change. So let's say we call this point, a lot of letters are coming here, A. That's the x value, which makes this point f at A. Do we agree? We don't know what the values are, but if it's A, that's got to be f at A. This point is A plus some small value. We're going to call h. For the whole chapter, h is going to be a very small value. My advice, use 0.01. I think the book in some questions uses 0.05 or 0.001, but as long as it's a very small value, you'll find an estimate for the instantaneous rate of change. So what's this point then? What's the y value of that point? Anyone?
It would be
Yep.
A plus H.
Yeah, f of a plus h. You just plug in the x value into the function. That's the y value. Okay, so now I've labeled my points, which means I actually have the x values and the y values of these points. Here are the x values, and here are the y values. So I'm going to create my slope formula. Okay, I'm going to subtract. Let me draw a secant here. Okay, and now I'm going to use a plus h and a plus h as my y1 or my y2. Okay, it doesn't really matter. I'll use it as my first point. So this is going to be f of a plus h minus f at a over a plus h minus h. I'll put these in brackets. Sorry, minus a. Okay, so this looks confusing, but it's not. All I did was take my y values and subtracted them, and then I subtracted the x values. You don't even have to look there. Once you get your y values, your x values are just going to be what are in brackets for that function notation. That's it. Just slap that there, slap that there. That's it, done. Okay, now I can clean this up a little because look at the denominator. Right, I have an a minus a. If I drop these brackets, I'm left with just an h. Okay, and this is my formula for finding an estimate of instantaneous rate of change, or I guess the exact value. And this is called the difference quotient. Okay, so it's one strategy to find instantaneous rate of change on one point. Now, let's talk about how do we estimate the instantaneous rate of change, and maybe how do we find it kind of exactly, which we won't do for maybe some time. Look at these 2 points. If this second point, this h value, is really, really small, what can you tell me about the distance between these 2 points? As h gets bigger, this point's going to slide this way on the x, right? Okay, if I'm telling you h is extremely small, what's going to happen with the distance between those 2 points?
There's not much.
Yeah, it's going to get smaller and smaller. There's not going to be much distance. So our job, we get to pick an h value, right? Our choice. If I make that h value 0, why is that not allowed?
Because you can't divide by 0.
I can't divide by 0. I would love to make the h value 0. If I make the h value 0, it means those 2 points become 1, and that's the instantaneous rate of change. But I can't mathematically do that. So I have to find another way. Another way is put 0.01 for now. If I plug in 0.01, these points are going to be so close together that it's going to kind of simulate the slope of that tangent, right? It's kind of like if you find 2 points really close together, the slope of the tangent, if those 2 points were 1 point, is going to be kind of the same. And if I make h even smaller, 0.000000001, I'm going to be really close to my exact answer. Okay, now, our job is eventually, as good math students, is to find a way to plug in 0, because plugging in 0.00001 takes long and is inaccurate, so that doesn't make any sense for us. So while it's a good strategy right now to estimate the instantaneous rate of change, we want to find a way to plug in 0 to find the actual value of the instantaneous rate of change. Okay, and that is definitely going to involve factoring and canceling out that h value. Once that h value is away from the denominator, we can plug in 0. But that's a later on thing. Okay, as long as you understand the difference between average rate of change and instantaneous rate of change for now, we're good. Okay, so 2 examples based on the same function. We have the volume of a cube. This is the formula for volume of a cube. If x is a side length and it's x cubed, then all the side lengths are the same, right? So it makes it a cube. So we want to find the average rate of change for the function v at x, the volume at x equals x cubed, where v at x is the volume in centimeters cubed and x is the side length in centimeters. So a lot of the times you're going to be given word problems that you actually might have to come up with a function, which is the harder version of questions. But more importantly, it's going to give you the units. Highlight them or something, because you need to put those units in your answer or you're going to lose half a mark. Okay, not really in multiple choice, but in my mind, you're losing half a mark. Okay, so and then it might give you an interval, or it might give you a point. It might ask you to estimate the instantaneous rate of change or find the average rate of change. So if you're given an interval, you know it's average because it's between 2 points. So we want to use the interval 4 to 6. I don't have a graph. I don't want to create a graph. I understand slope well enough to do it from the words. So what I'm going to do is I'm going to write down my formula for slope. Okay, do I always write y over x? No. But because it's the first day I'm doing it, I just want that constant reminder that it's always y over x. Because if I don't have that constant reminder because I haven't done it in so long, I might make a mistake and go x over y. It's a common mistake. Okay, so maybe do this for a few questions the first day, and then you can kind of skip it. So I want to find v at 6 minus v at 4 over 6 minus 4. So look at that notation. A lot of guys are probably confused right now. Why didn't you just plug them in and find the y values? You can, okay, but this is how we show exactly what we're doing. This is the y value at 6, this is the y value at 4. That information is not given in the question directly, right? It gives you the function and it gives you the interval, but it doesn't give you those values. So what you do, you plug in the 4, you plug in the 6, and you got the y values. Easy. If I plug in 6 into the function, what do I get? 6 times 6 times 6. 216. If I plug in 4 into the function, what do I get? 4 times 4 times 4. What's 216 minus 64 divided by 2? 76. Quick way to do this division in your head. Well, quicker way, might not be quick. Because they're both even numbers, just I would divide them both by 2. So here I'm doing 108 minus 32, 76. It's easier than subtracting larger numbers to then divide them by 2. If you can divide first, you always divide first. Get to those small numbers. If you wanted to do it in your head. It's faster than picking up a calculator, if you're good with it. M equals 76. Am I done?
How did you get 216 and 64?
I plugged in the value 6 into the function. So v at 6 equals 6 cubed, 216. Okay, that's a common thing you're going to be doing. You're always going to have to find the y values. You know, in grade 9, you're given a coordinate, x and y. Here, most of the time, you might be given just the x. You got to find the y with the equation that's given. All right? What am I missing in that answer? Units. What are my units?
Then, the third option that we might have are
Rate of change. It's always going to be the form of a fraction. And this one's going to be a little bit confusing. Okay, when in doubt, if you don't know how to do units, it's a good lesson for physics too, because units is kind of frustrating in physics. Plug your units into the values that, like from the first step. So what units go on top here? What units are my y's? What units are my x's? Read the question. This is technically the y value, and this is the x value. So the y value is centimeters cubed. Put it on top. The x value is in centimeters. This will never change. This is always the units of your answer. That's it. So centimeters cubed per centimeters. Now why I don't like this unit is because technically centimeters cubed divided by centimeters is centimeters squared. But the way this question is, we want to know as the centimeters change, what happens to the volume. So the rate of change is centimeters cubed per centimeter. It's just changing 76 centimeters cubed. The volume is changing by 76 for every change in 1 centimeter. And this is my answer. Average rate of change. Put that V4 here too. In case we're confused with how those numbers came up. And we're done. Any questions with that? Plugging in was the only difficult part, even though the difficulty is like 0 out of 10 once you see it. You just got to see it. Okay, next. Same question, but we only have 1 point. Okay, if you're ever told find the instantaneous rate of change, there are several strategies. I'm not going to get into all the strategies. I probably will afterwards. But try to use difference quotient because it's the best strategy. It can help you find the exact value. So, you got to remember difference quotient. Memorize that formula. If you don't, you can't even start. Okay, unless you want to envision 5 and 5.001 as your 2 points, like this question. You can do that. So I'm going to put that on the side over here. If you want to say that this is like an interval between 5 and 5.01, doing the average rate of change with those two numbers, exactly like we did here, will give you a very close estimate of the instantaneous rate of change. So you can do that. It's really easy. It's just as easy as this. Okay? Or you can do (4.99 to 5), or you can do 4.99 to 5.01. Okay, I'm going to get into these, but these are called preceding, centered, and following interval. Okay, this is a following interval because the 5 is what we're interested in, and we're using the number that follows. This is the preceding interval. Here's the 5, and this is the number that precedes the 5 using a very small h value. And this is called centered interval. Our 5's in the middle, and we're using small numbers on the outsides of the 5. Okay, they're all ways to find instantaneous rate of change, to estimate it. Okay, and you do this same way as this. All right, let's go back to the algebra. This is your formula. I'm going to plug everything into here. What's my A value? I haven't really talked about it, so I'll just tell you. It's always this. Your A value is that X value that I drew on that graph. Remember, I just called it A. It's the X value that you have to find the instantaneous rate of change. So this is going to be F of 5 plus 0.01 minus F at 5 all over 0.01. Remember, you can set H equal to whatever. We like to say it's really small, but I don't want to write that many zeros. So that's what we're going to settle on. Okay, it's really small, but how many zeros are you going to write? Okay, so now I'm going to need some help plugging in 5.01 into the function. What's 5.01 cubed? Who's got me?
125.751.
Give me more. 751.
751501.
Okay, so I want a lot of decimals here because I'm dividing by a really small number. So the more accurate I am here, the more accurate my answer is going to be. So be careful. What I do is I would write 125.751, but I'm not pushing cancel or on my calculator. Keep that number in your calculator, then subtract the 125, then divide by the 0.01, and you'll be accurate to like 9 decimal places. Okay, so be aware. Okay, so we want to subtract them. Those are going to cancel out, right? I'm going to move the decimal place over too, so it's like 75.1, looks like. 75. .1, .2, whatever. I'm just going to call it 75 because we're only dividing by 0.01. Okay, a lot of calculator work. You got to memorize this. You got to know how to use it, and the rest is easy. Okay, the rest is calculator work. Okay, so now I just want to take a look at these numbers. What are these? What do these mean? Sir, this is confusing. I don't want to use this. Do I have to? Yes, eventually. But we can use those as well. So if you found this to be way easier than this, which I imagine most of you do, convert it into one of the 3 types of intervals. I recommend centered interval, and let's see what happens. Okay, this is all I'm doing. I'm taking that 5, that value that I want to find the instantaneous rate of change. I'm finding small numbers on either side of them, and then I'm just going to plug them into my slope formula. You got me? 5.01 cubed? We already have it. 125, do the other one while I'm writing. 4.99 cubed.
124.251499.
Okay, and this is going to be divided by 0.02. Please? The quickest way to do this is 5.01 cubed minus 4.99 cubed equals done.
$75.0001.
Oh, you already divided by 2? Divided by 0.02?
Yeah.
Alright, fine. 75.0. How about that? Beauty. Okay, same answer. Okay, and this is using this. What we call centered interval. Most important thing out of today, for sure. This is grade 9 stuff, easy, which is good. This is that, but you have to kind of create it, which is good, right? I think this is pretty easy. And this will generally give like half of you a problem for some time. But this is most important in calculus, okay, or near the end of this course. You need to know how to do this. This is not even the difficult way of doing this, unfortunately. This is the easy way. Okay, I will show you just using an A value instead of that 5, so that you can rip out as many questions as possible using the same formula when you're finding instantaneous rate of change. Okay, when we do the same thing, like if I say x equals 6, we're going to do this all again? Or if I say x equals 7, we're going to do this all again? No, we're going to create a formula that works every single time, and then we just plug in those values into our answers. That's what we usually create in math. Okay, it's kind of like a little program to then go faster. Okay, and that's it.